In this experiment, you're going to have the chance to identify an unknown compound by doing a series of qualitative tests. So you will either have an aldehyde, a ketone, a primary, secondary, or a tertiary alcohol. And those may or may not have a double bond present. You will not have a mixture of an aldehyde and a ketone or an alcohol and an aldehyde. It'll be one of those 5 different compounds with or without a double bond. Now what we're going to do is observe the physical appearance, color, odor, and physical state. We're going to check the solubility in water. That'll tell us something about the carbon chain length. We're going to run a bromine test, and that will test for the presence of double bonds. And we might use potassium permanganate. We're going to use Ceric nitrate, 2,4-diphenylhydrazine, also known as Brady's reagent, chromic acid, or the Jones reagent. We'll do the Tollen's test, and then we will prepare derivatives and take melting points of the products of those derivatives. Lastly, we will determine what the refractive index is of our compound. So, generally when we do this, we will have to run your unknown, and then you're going to have to run positive controls. So you'll have to have compounds in which you know they should give positive results. And you should have some good negative controls too. Now let's take a look at some of the tests. So the test for bromination of alkenes. We want to do this in the hood because bromine has a particularly strong odor associated with it. But in the presence of a carbon-carbon double bond, bromine will appear essentially colorless. So if you take your sample and you throw it in with bromine and the solution becomes colorless, it means that you probably had a double bond present. Now, the same thing happens with potassium permanganate too. So here we have hexane and 1-hexene. With hexene, you can see that the solution, it's kind of a green color, but a brown manganese oxide is precipitating out of solution there. So that purple characteristic color of K104 disappears in the presence of that carbon-carbon double bond. Ceric nitrate is used to determine if we have an alcohol. So it gives you a positive test for primary, secondary, and tertiary alcohols. Now, having fewer than 10 carbons generally will give you a positive test. Now, what we're looking for here is a change in color from a yellow to some type of a red color. And often this can be a little bit masked by looking muddy, but what you're looking for is a color change. The 2,4-dinitrophenylhydrazine test, or the Brady's reagent, that will give you a positive test when you have an aldehyde or a ketone. They react readily with that compound to form 2,4-dinitrophenylhydrazones. And they range in color from yellow to red, depending on the degree of conjugation of that carbonyl compound. But by running controls, you can easily determine whether or not this is a positive or a negative test. Jones. So Jones oxidation is a rapid method for distinguishing primary and secondary alcohols from tertiary, right? Remember, tertiary alcohols cannot get oxidized. So we're looking for a color change from an orange color down to a greenish blue. Now that green color is often muddy because you have some orange unreacted Jones reagent laying around in the solution. But often if you just kind of shake the test tube up, you can see, for example, over in this third test tube that solution is definitely a little bit more, it looks definitely muddier, but not orange like you see with the Jones reagent bottle. The Tollen's test is a test that we use to distinguish between aldehydes and ketones. So aldehydes will react with the Tollen's test to give you this beautiful silver mirror. So we want to use test tubes that we don't care about here. We typically use disposable little sample test tubes because that silver is plated basically irreversibly on your glassware. Now, at that point in time, you should know if you have an aldehyde, a ketone, a primary, secondary, tertiary alcohol with or without a double bond. It's not going to help you figure out exactly what your unknown is because there's a large list of unknowns to choose from. So what we're going to do is we're going to take that list. That list is going to be, maybe 15 pages of different compounds, and they're organized by alcohols, aldehydes, and ketones. So if you know you have an alcohol, then you can at least look at, the first 6 pages or whatever, right? But to further help elucidate what the identity of our structure is, we need more data. And to do this, we're going to make a derivative. And we're going to take the melting point of that derivative. So all of your unknowns are going to be liquids. And we don't want to take the boiling point of the liquid yet because heating that liquid could change the chemical structure because it could oxidize with oxygen, for example. So if you think that you have an alcohol, the derivative that you're gonna make is 3,5-dinitrobenzoate. It's the alcohol derivative. There's lots of other ones, but we're just making this one. Now that compound will take 3,5-dinitrobenzoyl chloride. So this is kept in a sealed container with desiccant because this functional group here is easily turned into a carboxylic acid in the presence of water. And you'll add your alcohol, and then you'll make this derivative. So that will be a solid. It PPTs out a solution. You'll have to purify it, and you'll take the melting point of that. Now, if you think you have an aldehyde or a ketone, you will take the melting point of the derivative 2,4-dinitrophenylhydrazine. So again, there's lots of different derivatives. We're just going to make this one. So this is the formation of the 2,4-dinitrophenylhydrazine. So down here at the end of this little abbreviated mechanism, that's the compound that you're going to be isolating, right? With our R groups being different depending on what your aldehyde or your ketone was. Now, that'll help us narrow things down further. And hopefully at that point in time, you've narrowed your choices down to 2 or 3. You'll then take the refractive index, and you'll have to use this formula to adjust your refractive index to 20 degrees. And you're going to have to look up some values. You can look up the refractive indexes of the 2 or 3 compounds that you've narrowed your choices down to in the Merck index, for example. That's a good place to look. And then hopefully with all of that data, you'll be able to completely identify what the identity of your unknown is.